All right, so let's start maybe from the architecture. Where's my, there we go. So what we're trying to achieve here is to create a simple architecture which is offline first. So information like events on site is persisted in locally on active peers in an embedded database. Why embedded? Because we don't want to install stuff like SQL Server, database server, and maintain it. We want to minimize maintenance on site. In case of multiple Weighbridges on site, they all act as active peers. They sync data in real time with the help of gRPC. And also, opportunistically, we sync data to cloud, which is in our case Kafka. And Kafka is very handy for event sourcing that we are going to have. Now, why event sourcing? Because everything happens on site to us as an event. An event has an origin, a timestamp, an ID, transaction ID it relates to, and events are immutable. So you can't change an event. You can only add an event to a transaction but not change existing event. So this data is very easy to sync. It always goes from one direction. It has one origin. And that's intentional by design. So why peer sync? Because we often have, for example, a driver driving on bridge 1 and driving out on bridge 2. So this data ideally should be syncing in real time to mark same transaction. So now let's go to our code or to our application running. So we have a site with two Weighbridges. On my left is bridge 1, on my right is bridge 2. And we've got a POC client app which does a simple transaction like wait in, wait out, and a payment. So we start, we connect to bridge 1 on port 80, we send an event. So one bridge is receiving client event from the application, and the second bridge is receiving peer event with the same data from a peer. Now, I can actually connect to the other bridge and say I'm driving out. So in this case, it will be reversing. So bridge 1 will be receiving peer event, but data will come as client event on bridge 2. And we finish in payment, transaction is done. Now, because we have Kafka, we can also peek into Kafka, and this is our cloud site. We've got the Kafka instance called Cloud Event Sync, and it has a UI. Can open it here. Kafka has topics. Topic name is tenant ID dot site ID dot events. So every tenant and site is segregated. There is no data leak by design. And here we can see events. So the last one should be payment, and then it's wait, and then it's also wait. So everything syncs nicely when we are all connected. Now, what happens if we say shut down one bridge? So let's just do that. I stop intentionally bridge 2, so it's not running, but I can still do transaction on bridge 1. So start, connect to bridge 1, send an event. There will be some errors from gRPC on bridge 1 because it can't send it to bridge 2, which is expected, but that's not critical. So then I complete transaction on bridge 1, but all peer events are saved in outbox designated for bridge 2. So once I start my bridge 2, I should be receiving 3 events that are outstanding after a few seconds. So let's see that's happening. Yeah, so 3 events, which is Wayne, and payment with 3 different IDs. So that is achieved by storing offline data in Couchlight at the moment. This is our embedded database, and it has a structure. It has all events offline, and also outbox for every destination. So in case there is loss of connectivity or peer is going down, there will be events piling up here, but then they are retried and removed once they been confirmed and sent. So gRPC is very reliable, right? It's a request response. So for every request of the event batch, we get a response or error. So based on response, we can assume that it's received by peer 2, and we can remove it from the outbox. So that just works, right? We click on outbox bridge 2, there's nothing there, and it all reliable, so no message is lost. Everything is eventually synchronized. Okay, so the other bit that we have in our architecture is the reference data, and we say we sync it in one direction, from the cloud on opportunity to the site, because we don't want people on site editing stuff like products and vehicles, because they should be administered from the cloud. And in my case, this is MongoDB. And why? Because MongoDB has this nice feature of collection watch. So once my client Weighbridge is connecting to the cloud, it gains connection to Mongo. So if I say edit a zone object here and give it a different name, I should be receiving event in my application. So let's update here. And I hit a breakpoint in Visual Studio. So there's an event coming from Mongo to my connected site once it's connected, and I can update myself on the fly. And it goes again to my offline data, which is in my collection here, configuration zones. So my item here has updated. Right, so I guess that's it is in a nutshell. It has peer-to-peer sync, active peers, no masters, no slave, no database to manage inside, and also Kafka, which is very handy to sync events. So it's not overly excessive, and I think we've got all the bases already in place which we can build upon. So thank you very much for watching this video.